In this video, we are given that x is between -3 and -2 and y is between -1 and 2. We're trying to find an upper bound of x squared plus y squared and xy plus 3. Sorry. So we also gonna find a lower bound for these two quantities. Okay. Sometimes when we are interested in finding optimization, we have to deal with this one. But the problem is we don't jump directly into the solution. We have to be careful to solve these problems. So let's say we want to find x squared. Okay. So given that our x is between -3, -2, and if we just square x squared everything, we get x squared is between 9 and 4, which is completely wrong. Okay. So what we do here in this case is that we multiply by minus x. We get minus x is between 2 and 3. Okay, and we have minus x between 2 and 3. And minus x times minus x is x squared. This is a positive number. This is a positive number. The same thing for here. Nothing is going to change in these less than or equal signs. So we have x squared is between 4 and 9. Okay? So when we are dealing with this number, we have to be careful. Make everything positive or everything negative, but be careful. Be careful what you are computing. Okay? If we are computing 3x, yes, we are not going to switch anything. But when we are dealing with x squared or square roots or anything, make sure to pay attention. For the y, now, we have y is between -1 and 2. And we are asked to compute y squared. The same thing, if we jumped and computed y squared, we're going to find that y is between 1 and 4. But this is not true, okay? Since we can have y can be between -1 and 0 or between 0 and 2. For the positive one, we have y squared is between 0 and 4. But for this one here, we have to make this one positive. So we multiply by minus y to get 0 and y and 1. And now we multiply by minus y, the same thing as we did for the x. So we get y squared is between 0 and 1. And again, using both results, we see that y is in this interval between 0 and 4. We can conclude that y is between 0 and 4, not between 1 and 4. So therefore, we have x squared is between 4 and 9, and y squared is between 0 and 4, and adding these two, in addition, we have no problem. So it's between 4 and 13. Okay? We need to be careful when dealing with this one. A lot of mistakes happen. Okay? The other thing is we want to compute xy plus 3. X times y plus 3. Okay? So when dealing with this kind of numbers, okay? So we want to make sure that we have either the positive ones. So let's say, so x is between -2 and -3 and -2. So we have minus x is between between 2 and 3. For the y, so we have first one is y between 0 and 2. Okay, now these two numbers are positive. We can just multiply. We get minus xy. It's between 0 and 6. And using multiply by minus sign, we get xy is between -6 and 0. Okay. The other case is when y is between -1 and 0. Okay. Using a minus sign, we have minus y is between 0 and 1, and we have x is between minus x is between 2 and 3. We multiply, we get xy is between 0 and 3. Okay, so that means our xy is between minus 6, okay, and 3. And we add 3 to both sides, so we get minus 3 xy plus 3, 6. We have to be careful when dealing with these computations. So we have found an upper bound for xy plus 3, which is 6, and a lower bound for the same quantity, which is minus 3. The same thing here for x squared plus y squared. We have found an upper bound of 13 and a lower bound of 4. So sometimes in R, this x squared plus y squared is like this. If you graph it, you're gonna see it's like this, something like this. So this is x, y, z. Okay, so you wanna find, given our axis, the values of x here and the values of y's. You wanna find where x squared plus y squared is sitting, assuming that this is the quantity of something that's here in this volume. We'll see it later when we deal with engineering problems. But for now, pay attention when dealing with finding upper bounds and lower bounds for quantities that sometimes are positive and negative. They don't have they have variable sign. Okay, you need to be careful when dealing with this one. Okay, if you have any questions, please comment and contact me if you need anything. Thank you very much.